Today, we are diving deep into something we see, drink, and use every single day: water. But trust me, we're going to go way beyond the basics. We're going to uncover its surprising and honestly mind-blowing role inside your own body. So let's get into it. This quote from scientist Yuan Li just nails it, doesn't it? It completely reframes water. It's not some boring everyday liquid. No, it's peculiar. It's this wonderfully strange molecule whose unique properties are the only reason life as we know it can even exist. And get this, that same peculiar substance isn't just out there in the oceans and rivers, it's right here, inside you. About 60% of your body is made of this exact molecule. So, in a very real sense, you're a walking, talking vessel of this organized, life-giving water. Which, of course, just begs the question, right? What are its secrets? What is it about this simple little combination of hydrogen and oxygen that makes it the absolute cornerstone of our entire biology? Well, to answer that, we've got to zoom in. I mean, way, way in, down to the molecular level, because that's where water gets all of its incredible superpowers. We all know H2O, right? But the real secret isn't just the atoms, it's the shape. Look at that specific 104.5-degree angle. The molecule is bent, it's not straight, and that bend creates the slight electrical imbalance, what we call polarity. It gives the oxygen side a little negative charge and the hydrogen sides a little positive charge. This one feature, this is the source of everything. And because of that polarity, water molecules start acting like tiny, weak magnets. The positive end of one molecule gets naturally pulled toward the negative end of another one that's floating by. And that attraction, it has a name: the hydrogen bond. This is the whole shebang. It's what links trillions of water molecules together into this huge interconnected network. It might be a weak bond, but it is the secret to everything that makes water so special, why it sticks together, why it regulates temperature so well, all of it. And hey, don't just take my word for it. The two-time Nobel Prize winner Linus Pauling said it best. This humble little hydrogen bond is, without a doubt, the true architect of water's life-sustaining power. It's a really big deal. Okay, so now that we get the power of that tiny little bond, let's zoom back out. Let's see how this all plays out on a grand scale, inside what you can think of as the body's vast internal ocean. I mean, look at all the jobs it does. Inside you, water is just a tireless worker. It's the universal solvent, dissolving nutrients so your body can actually use them. It's a master temperature regulator, soaking up heat so you don't overheat. It keeps your pH stable, it's the taxi service for vital molecules, and it even gives your cells their physical shape. It is quite literally the stage where all of life's processes happen. And this chart shows us exactly where that internal ocean is. It's fascinating. A staggering 40% of your total body weight is water that's inside your cells. The other 20% is outside them, some of it bathing your tissues and the rest flowing through your veins as blood plasma. But here's the thing, keeping this internal ocean perfectly balanced in terms of volume and what's dissolved in it, well, that's not simple. It requires this constant, sophisticated, and incredibly delicate balancing act. Take this number, for example, 2,500 milliliters. That's about 2.5 liters. It's the average amount of water a typical adult takes in and loses every single day. You take it in through food and drink, and you lose it through urine, sweat, even just breathing out. And for you to stay healthy, those two numbers have to match perfectly. So how does your body know if things are getting out of whack? It's constantly checking a key metric called plasma osmolality. Now, that sounds complicated, but all it is the concentration of your blood, basically how much stuff, like salt, is dissolved in the water. This one measurement is the master signal for your hydration. And when that osmolality rises even a tiny bit, meaning your blood's getting too concentrated, this beautiful, precise feedback loop just kicks into gear. First, sensors in your brain detect the change. Then, your brain creates that feeling we all know, first. At the same time, it releases a key hormone. And that hormone zips down to the kidneys with a simple, urgent command: hold on to more water. And the absolute hero of this entire system is that hormone. It's called antidiuretic hormone, or ADH for short. Its name literally means against urination, and yeah, that's exactly what it does. This chart shows you its magic trick. Without ADH, the final tubes in your kidneys are pretty much waterproof. Water just flows right on by and you pee it out. But when ADH shows up, it's like a foreman on a construction site. It tells the kidney cells to install these tiny water channels called aquaporins. Suddenly, the walls become super absorbent and water rushes back in your blood. It's just an ingenious, on-demand water-saving system. Now, this system is amazing, but it's also incredibly fragile. And to really appreciate the life or death importance of getting this balance right, we have to go where the stakes are the absolute highest, the intensive care unit. See, in critically ill patients, those automatic balancing systems often just fail. The situation gets so messy, with problems of both too little and too much water, that doctors have started calling it water disease. And this is what water disease can look like. On the left, a healthy lung. On the right, a lung with pulmonary edema. This is what happens when there's way too much fluid in the body. The tiny blood vessels start to leak, and they flood the lungs' air sacs with water. It impairs oxygenation. It is, quite literally, drowning from the inside out. And the damage doesn't stop there. Here's what happens to the kidneys. All that extra fluid causes massive congestion and swelling. This can trigger acute kidney injury, shutting down the very organs that are supposed to be regulating water in the first place. It's a vicious cycle. So you can see, doctors in the ICU are walking a physiological tightrope. It's an impossible balancing act. Too little water and organs don't get enough blood, which can lead to coma and death. But too much water and tissues get waterlogged, organs fail, and we know it directly leads to higher mortality. It is a razor's edge with life or death consequences on both sides. Which brings us to a final thought. We've all heard that phrase that we're basically just walking bags of water. But after seeing the incredible, mind-boggling complexity needed to maintain that internal ocean, it leaves us with a pretty profound question. If we really are just bags of water, how fragile is the bag itself?